In this lesson, we're going to start getting into the heat exchanger, which is the only component in a gas furnace that protects the homeowner from the products of combustion. Whether you are on a maintenance or on a service call, the heat exchanger really should be inspected for any sort of wear, cracks, or any sort of deformities whatsoever. Because if we miss something in a heat exchanger, we honestly can do harm to the people and the occupants that are actually using this device. So with heat exchangers, the heat exchanger is in a furnace is a chamber where the heat of combustion is transferred to the surrounding air. Heat exchangers are sealed to prevent any combustion gases from mixing with the air that will be circulated through our conditioned space. Heat exchangers have two jobs during the heating process. The first job is to heat the circulating area in the conditioned space, and it is to carry the combustion gases to the exhaust flue or vent where it is now released to the outdoors. So heat exchangers are categorized into two separate areas. We have a primary heat exchanger, and we can have a secondary heat exchanger. Okay, the primary heat exchanger is connected directly to the combustion chamber and transfers sensible heat from its surface to the air circulating through the conditioned space. Primary heat exchangers can be constructed from a variety of materials that provide different rates of heat transfer. So we can look at this picture here. This is from a high efficiency 95% gas furnace. The bigger tubes that you see, that's our primary heat exchanger. That's where our flame from our burner usually will get shot into, the bigger tubes. The secondary heat exchanger, which is kind of down there below, kind of almost looks like a coil, that is our secondary heat exchanger. That is where we pick up latent heat from our combustion process and use that heat to increase the furnace efficiency. It is where, in that area of our heat exchanger, we are now able to lower the flue gas temperature to around 100 degrees for our high efficiency furnaces. When we are inspecting these heat exchangers, we want to see and look for any signs of wear, any sort of cracks, rust, or any sort of deformity whatsoever on these. These heat exchangers should be intact. And when I mean intact, there should not be any signs of cracks or wear and tear on them. Okay, high efficiency furnaces are equipped with that secondary heat exchanger. The secondary heat exchanger is attached to the primary heat exchanger and transfers sensible and latent heat from the combustion gases to the circulated air. Now, older furnaces may not have that secondary heat exchanger. Your more traditional furnaces would quickly exhaust the combustion gases and lose some of its heating potential out the flue, which obviously made them lose efficiency. These furnaces use the old style clamshell type heat exchangers, as you see here in this picture. Basically all they were was two pieces of metal that were formed and stamped together or welded together. These type of furnace heat exchangers used to have a leakage of around 5%. So which that meant was that some of the combustion gases did kind of leak out into the circulated air, but because of the amount of air going across the heat exchanger, that leakage was usually diluted, and it didn't really cause any sort of like health issues with them. The pressure created by the blower motor kept those flue gases in the heat exchanger and out of the space. Your condensing furnaces, however, those are a lot more highly efficient and usually have an AFUE, or annual fuel utilization efficiency, rating of above 90%. These furnaces differ from those traditional furnaces because of the use of the primary and secondary heat exchanger. So in your condensing furnaces, the heat is extracted for a longer period of time until the combustion gases gives up enough heat to start condensing, hence the name your condensing furnace. So how does this happen? Well, first, the combustion gases pass through the primary heat exchanger, and then they go into the secondary heat exchanger. And then that's in the furnace, that circulating air that passes over both of those heat exchangers in the opposite direction will now cause that heat to be given up and now sent into your conditioned space. So when the air passing over the secondary heat exchanger first, it is able to absorb the maximum amount of heat possible, including your latent heat, which is released from the combustion gases as it condenses. It will now pass over the primary heat exchanger, where even more heat is absorbed. The heat is removed from the combustion gases until it condenses. Since condensing furnaces have lower flue temperatures, your combustion gases can now be routed out using PVC or CPVC instead of using a chimney or your old metal flue pipe. Okay, most condensing furnaces are gas-fired. Your non-condensing furnaces usually had an AFUE somewhere around 70%, and they utilized a drum-style heat exchanger. These types are manufactured. They're not manufactured anymore, but they do still exist. These drum-style heat exchangers almost kind of look like a 55-gallon drum, just big old monstrosity type heat exchangers. The fire and combustion air was inside, and the space or the conditioned air would blow across the outside of these types of heat exchangers. These furnaces have a lower efficiency AFUE rating between 80 and 90%. They also have a single heat exchanger that transfers heat from the combustion gases to the circulated air in the space. And then the combustion gases are vented to a flue or chimney with a flue liner and have up to about 20% of the heat being generated lost up the chimney. So during your pre-winter inspections and service calls like that, heat exchangers need to be checked for cracks. Okay, carbon monoxide can seep through the cracks in the heat exchanger and into the conditioned space. A cracked heat exchanger must be replaced. We cannot repair them. We cannot ignore the problem. Heat exchangers are not meant to be fire caulked, not meant to have sheet metal screwed into them with fire caulk and all crazy stuff that you're probably going to run into. If a heat exchanger is cracked, that furnace needs to be shut down and rendered inoperative. It is a health problem. You can honestly kill somebody if you leave that heat exchanger on and that furnace in operation. Be careful, though, when diagnosing a cracked heat exchanger. What you're going to want to do is you're going to want to document everything. If any doubt have another technician or have somebody come and have a second opinion on it. Okay, cracked heat exchangers most often mean a replacement of a furnace, because a lot of times it's going to cost more money for a customer to have the heat exchanger taken out of their existing furnace and put a new one in than just having a brand new furnace put in. Okay, they do not crack on their own. There is something that has caused that crack to happen. Okay, we have to find the problem. That is our job. Anytime we come across a compromised or broken heat exchanger, we are the ones that should find the problem so that it doesn't happen again. Now, common causes for your premature heat exchanger cracks. One of them is most likely going to be airflow. Okay, dirty filters, blocked or closed off air vents, furniture, blocking your return air vents or supply air vents, all contribute to proper airflow for that unit. Now remember, when it comes to ductwork, your return air vents, your supply air vents are all meant to be open and unobstructed. If there is something that is blocking them, or a vent that is blocked, or what have you, you are now interrupting the flow of air through that unit. That's going to cause a problem. Improper combustion of gases. Okay, they go hand in hand with the airflow restrictions. When your burner is not firing properly, they can run hotter. They're going to lose efficiency. That unit is not designed and is not working the way it's supposed to be. Improper displacement of condensation. Most common in furnaces that have not been run in heat or cool for a very long time. Condensation accumulates in the heat exchanger, eventually causing rust. And when that rust is sitting there for a while, it's going to eat away at the metal, and the metal is just going to become fragile and it's going to crack. The life of a heat exchanger is around 20 years with regular gas furnace maintenance. Okay, gas packs or gas package units are known to wear out faster than other units since they are exposed to weather and unsusceptible to heating and cooling, and most importantly, condensation cycles more often. Heat exchangers found on rooftops is a prime example of this. The heat exchanger is up on the roof. It's in that unit up there. It's cold outside. It's going to be exposed to extreme weather conditions. That expansion and contraction of the metal is a lot greater than a furnace that is in a residential home. So those types of heat exchangers are going to wear out a lot faster than those in a regular residential furnace. So here's an example of a cracked heat exchanger, of an old clamshell heat exchanger. Now, where you're going to look for a lot of cracks is going to be on the bends or sharp edges of your heat exchangers, because chances are that's where they're going to crack first. Now you can look on this, you can see that there is a lot of rust. That rust is a sign of condensation. Okay, so you're going to want to look at areas of where all those rust parts are. Now, obviously, in this picture, that's a pretty definitive crack. Now, you were to come across that furnace would be shut down and rendered inoperative. Now, here's another example of a crack. Now, you can kind of see it's defined, but it maybe could be a little bit harder to find. So you're going to want to inspect your heat exchangers as best as possible to find any sort of deformities or any sort of issues. Now here is a rooftop heat exchanger. Okay, again, notice where those cracks are, right on the bends. That's usually where they're going to crack. Now here is an example of a clamshell old style heat exchanger, but notice how the deformity is. Look at the discoloration on that metal. That is a form of thermal fatigue. That is just a overtime constant expansion and contraction of the metal, and that metal just worn out. Okay, that could also be a sign of the furnace overfiring for probably for several years. So you're going to want to see and look at stuff like this to try to find what has caused these cracks. Now, in this video here, I want you to watch this flame pattern. You will notice that this flame pattern is going to change, and that is a sign of a cracked heat exchanger. Yeah, you see how that flame pattern changed? Once the blower turns on, the indoor blower turned on, you saw that flame start to wobble around and jerk all over the place. If that heat exchanger is solid and there are no cracks, that flame should stay relatively steady. But there you can see that that flame started to jerk around right as soon as that blower turned on. That's a sign of a cracked heat exchanger. Now, you can do that with a simple grill lighter, as you see here in the video. You don't necessarily have to turn the burners on to see whether or not a cracked heat exchanger is cracked or not. However, there are cracks in a heat exchanger that may not necessarily show their ugly face when the heat exchanger is cold. So sometimes this test may not necessarily work. So my recommendation in a lot of cases is to do it in both ways. Do it, you know, with just the blower on with a simple little grill lighter. Go across each one. Then do it with the burners on the furnace actually lit and watch the flame pattern to see whether or not the flames actually change. The reason why I say to do it that way is because there are sometimes hairline cracks in the heat exchanger that will not necessarily be opened enough to allow any sort of air to kind of make its way inside the heat exchanger. So we have to allow the metal to kind of expand a little bit. And when that metal expands, the crack is going to widen. And when that widening happens, you'll actually see the flame pattern actually change. You can also purchase a camera that you can kind of stick into each one of the clamshells, which you can actually kind of see the interior of the heat exchanger. Using a flashlight, if you're going to use a camera, is a great way to see whether or not you have a crack, because if there's any sort of cracks in the heat exchanger, the light is going to shine right through and you'll see it. But you're going to want to definitely check your airflow on your furnaces, because chances are that's probably going to be one of the biggest reasons for a heat exchanger to crack. So what you're going to do to diagnose any airflow problems is you're going to take your temperature readings of your supply and your return air. You're going to take those two readings and you're going to subtract the two from each other. And that's going to give you your delta T, your temperature difference. Then you are going to use the output BTU from the nameplate into the following formula. Okay? Your output BTU divided by 1.08 times your delta T. You're going to compare the calculated value against the recommended value from the manufacturer. Check the temperature rise, delta T, against the temperature rise on the nameplate of the furnace. And the temperature rise is the difference between your supply and your return air temperatures. You're also going to check your blower. You're going to make sure that the blower wheel is clean. Stuff like this cuts down on airflow across your heat exchanger. Remember, a blower only knows one thing. It knows to circulate the air in the system. It does not know whether or not the blower wheel is actually clean or not. You have to check your blower wheels to make sure that they are clean. You have to make sure that they are going in the correct direction. If you do not do it, you're going to have issues. Now, why does this cause issues? Well, just like I said, your blower knows one thing. It knows to take the air and circulate it. Your blower wheel and those fan blades are curved. They are curved to throw air. Catch it and throw it across the heat exchanger. When I have an accumulation of dust and hair and God knows what else on that blower, I am now cutting down on the surface area of that blower wheel. I am cutting down that blower's ability to throw the correct amount of CFMs across my heat exchanger. And when I do so, I am raising the temperature of the metal. And when that happens, I can now start having that thermal fatigue, and I will now overexpand the metal of that heat exchanger, and I can now cause a crack. Or doing stuff like this, blocking your air vents. Okay? Stuff like this is a big old no-no. You don't want to see any of this happen.